So this track that you can see here is supposedly the track of a hotspot that came up underneath Greenland about 70 million years ago. And basically the hotspot means that the area has tracked across a mantle plume. I'll explain that a bit more in a minute. And that is now situated under the mid-Atlantic ridge, under Iceland. In fact, it's actually in the southeast of Iceland. And that is the reason that Iceland is an island and not just a bit of very submarine ridge. Its basalts are chemically enriched from the mantle, because you've got deep mantle upwelling, so you've got different chemistry in there. So it's enriched, so it's called E-morb, as opposed to N-morb, which is normal morb, or D-morb, which is depleted morb. So enriched mid-ocean ridge basalt. And what that means is, so this is pretty much the picture I showed you before is pretty much that bit up there. But this has a contribution from way, way down in the lower mantle and possibly down at the core boundary. Chemically, they're distinct. So this is the range of chemical values. These are a whole bunch of elements all the way along here, the heavier elements. And that's E-morb. This is N-morb, normal stuff, and a bunch of other ones from other places. So quite distinct, quite distinct. So let's talk about this. So here is our a plume rising from it. So something happens very deep down at the core mantle boundary, and you create a heat pulse that produces some melting, and a plume rises up through the mantle. That brings fluid, liquid, and heat, a lot of heat, from right from the inside of the Earth. So it comes all the way up, and when it hits the surface, what you get are flood basalts. You may have heard of flood basalts, but basically they cover a big, long area. They're almost certainly one of the causes of mass extinctions, because they go on for a long time, they cover a lot of area and produce a lot of gases. So that's pretty much what happened under Greenland about 60 million years ago. There's flood basalts on the west and on the east of Greenland. This is squeezed back together. So, and then you've formed the ridge, you've got spreading going along through here, but this is 25 million years ago, Miocene, and you've still got some heat coming up through here, so you get the Iceland plateau. And that's because basically, although the plume itself has probably gone, which is why we're not getting flood basalts anymore, what you do still have is this tail, which keeps coming up and pulsing and producing, and in particular, bringing heat to the surface. So the current situation is like this, plume-generated crust in this sort of area through Iceland. So what that means is that you've got this amazing pattern of basalt across the whole area. So the original flood basalts were here and here, but then you've got the whole Faroe Island plateau all the way down here, and basalts all the way across here. These are equivalent, then it's just being narrowed down to now it's just on Iceland.